All right, let's look at your final exam review. The first portion is the written portion that I'm going to be giving on Tuesday. That's A, B, C, and D. You should understand all those. If you don't, look them up online. Go to YouTube. Then you have 1 through 38. That's going to be the next day. That is your multiple choice. You should know all those terms: amplitude, antinode, crest, etc. You can go to your book or you can look them up online. 39 through 56 are examples of some of the terms that you see on the previous page. Let's look at 39. Calculate the amount of work required to lift a 20 kilogram box up a staircase whose height is 5 meters. The first tricky part to this is I gave you mass, I gave you height, but I did not give you force. And the equation for force, of course, is work is equal to force times distance. But we don't know force. So we do know force is mass times gravity. So I replace force with mass times gravity. Mass times gravity times distance will be the equation. And I filled it all in. You got 980 joules. Let's look at problem 40. Let's look at problem 40 here. It says, what is the potential energy of the melon before it starts moving downward? They didn't give you the mass of the melon. I'm sorry about that. The mass of the melon, let's say, is 15 kilograms. The equation we use for potential energy is equal to mass times gravity times height. So we have 15 kilograms times 9.8 times 13. And the answer is 1,911 joules. That's the potential energy. 41 is pretty easy to do. What is the potential energy of the melon as it strikes the ground? There is no potential energy once something reaches ground level. In other words, if you have a brick, let's say on a step ladder, it's got plenty of potential energy. You put the brick on the ground, it has zero potential energy. 42. Calculate the kinetic energy of the melon just before it strikes the ground. Well, the potential energy gets changed into kinetic energy. In other words, the melon that was at the top when it was originally 15 meters high, it had all potential energy, zero kinetic energy. Now that the melon's about to hit the ground, it has zero potential energy and all kinetic energy. So therefore, the kinetic energy is equal to what the potential energy used to be. So that's 1,911. There's no calculation necessary. 43, explain why the results are the same in problem 40, 41, and 42. I don't want to say they're the same because, of course, 41 is not the same number, but the whole concept of this is the conservation of energy. So 43 is the conservation of energy. Let's look at number 46. 46 is what we've been doing all last week. You have a piece of glass, and or I'm sorry, this is water, and then we have air up above it. You have a piece of light coming in, and then it refracts. And they say it refracts at an angle of 41 degrees. So in this case, we're given theta 2. We don't know theta 1. We know the index of refraction of air is 1.00. The index of refraction of water is 1.33. And all we do is use Snell's law. Snell's law says n1 sine theta 1 is equal to n2 sine theta 2. We just rearrange the equation. We have theta 1, let me change that to theta. Theta 1 is equal to sine negative 1, and then you have to take, once again, this whole number here in parentheses. Don't try to do it without parentheses, otherwise it won't work. Put it to your calculator, and you get 61 degrees. So theta 1 will be 61 degrees. So this beam was coming at an angle of 61 degrees to the normal, and it refracted to 41 degrees. 4748 has to do with frequency and velocity. It's those two formulas. 47 is a pretty simple equation. A water wave has a wavelength of 3 meters and a frequency of 0.75 hertz. What is the velocity of the wave? You have a couple of equations to choose from. Velocity of the wave is equal to wavelength over time, or since time period is really just 1 over f, theta is equal to, velocity is equal to wavelength times frequency. We'll use this one. So we have 3 meters is the wavelength, 0.75 hertz was the frequency, and you have an answer of 2.25 meters per second. Number 48 says the wavelength of a photon of visible light is 3.5 times 10 to the negative 6 meters. What is the frequency of this light? You're using the same equation. Velocity is equal to lambda times frequency, or this is lambda, wavelength times frequency. It must be solved for frequency, so we divide each side by lambda. We just plug and chug, and our answer is 8.57 times 10 to the 13th meters per second. Don't forget 49 for the resistance total for a circuit in parallel is 1 over RT. And do not forget, just RT is equal to R1 plus R2 plus R3 is for series, and I will have that on the test. Number 50, velocity equals current times resistance. Rearrange the formula and you have 2.25 ohms. For number 49, we have resistors in parallel. Here is the formula. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. You get the answer, and then you must take the reciprocal of your answer. You must hit the x negative 1 key on your calculator, and the answer is 1.84 ohms. Looking at 50 says determine the resistance of a light bulb filament. Well, we're going to use Ohm's law. V equals IR. R is equal to V over I when it's rearranged. 9 volts, 4 amps. Our answer is 2.25 ohms. 51 are pendulum equations. Time is equal to 2 pi square root L over G. You should look that up. 53 is a torque problem. 51, 52, and 53 are pretty easy questions. 51 talks about the time period of the pendulum. The pendulum formula is as follows. You just plug and chug, get the answer. 52 is exactly the same question with different variables. You just simply put 2 pi square root of the length of the pendulum is 5.6 meters. Gravity is 9.8 meters per second squared, and you land up with 4.75 seconds. 53 is a torque problem. Remember, torque is simply force times radius, or force times the length of whatever you're using, a shovel or a wrench or what have you. And there's an 18 Newton force put to the edge of a wrench that is 0.36 meters long, and we have a torque of 6.48 Newton meters. 54 is a similar question. It says how long is a pry bar to produce this particular torque? We simply rearrange the equation to solve for radius, which is the length of the pry bar. Put the numbers in, and you have 11.9 meters. 55 is if you have it says what is the direction of the magnetic field? If you have an electric current running through a wire in this direction, you use the right hand rule. You get this as an answer. Number 56, they ask what is the direction of the current given this magnetic field here around this particular wire. You use your right hand. You can tell that your thumb points in this direction. which means it's moving positive to negative.